So what's up, YouTube? I'm here today with another peer. I'll allow him to introduce himself. I'm really excited to interview him. So if you can introduce yourself in terms of what's your name, where you're from, and what's your major of study, and where you study currently, that would be great.
Sure. So I'm Jeff Bardstra. I'm from Boise, Idaho, originally. Um, I am currently studying to get my PhD in mechanical engineering. I'm doing that here at MIT. I got my master's here a few years ago. I did my bachelor's also in mechanical engineering at Syracuse.
Awesome. So yeah, me and Jeff both went to Syracuse. I did my bachelor's in aerospace and my master's in mechanical and aerospace there. And so yeah, we both went there. He decided to go more into research. I went into the industry, but I'm excited to ask you about so getting into studying at MIT. So I want to give people perspective on what it's like working in the industry versus doing research and staying in academia. I've already interviewed a lot of people that work in the industry, but since you're in academia, especially at a tier one school when it comes to research, I want to know more about your research. So what does your research consist of? I saw on your LinkedIn profile was a pretty technical description. Let me see. I just want to read the
I
first.
haven't updated that in a long time.
It says I'm just going to read the first sentence. Computationally exploring the nanoscale infiltration behavior of water molecules in MF1 zeolite pores through molecular dynamic simulations for application as a desalination membrane. Is that still accurate?
No. I guess I've done a very bad job of keeping up with my LinkedIn. That was my undergraduate research.
Really? Oh.
Yeah. As a graduate student, no, I don't do that. So lately, what I've been doing is honestly pretty like fundamental academic stuff, like exploring, trying to understand better the kinetics of evaporation and condensation processes. But I also do some more practical things, like we do modeling and design of evaporative cooling devices. I was especially doing this for my master's degree. So these were like, say like evaporators that you would put on high powered electronic devices. Because in those, they're near, like electronics are high powered, means they also generate a lot of heat. So it's actually quite a challenge to remove heat from electronics. So that's kind of like the applications of what I do. And, we do a little bit of design in that space as well.
Okay, so I know I'm familiar a little bit with like heat sinks on computers because I used to build gaming PCs. Is it similar to that? And I know a lot of it was very critical to get the right size heat sink with all the fins and the fans to do the heat transfer process. So is it similar to that? Are you doing that more on a nanoscale? Or is it, what is the research related to? It sounds like you're talking a little bit about heat transfer as well.
Yeah. So like I'm in a heat transfer lab. So I guess I'm a heat transfer engineer. So yeah, it's pretty similar to the heat sink. So actually, if you have a laptop, your laptop almost certainly has a thing called a heat pipe. And a heat pipe uses evaporation and condensation to very efficiently move heat away from the processor over to like the heat sink or somewhere the laptop can let out the heat. So those are the kind of things that we're designing evaporators for. Yeah, this is actually like kind of, I think, a big direction these things go.
Yeah, especially as we try to cram more processors into computers and things like that. Is there a special type of material that you guys have in mind, or are you guys still using copper? I know that's kind of like what the industry uses for heat sinks right now.
Yeah, so we do a lot of like very academic research, like, okay, if we make these kind of structures, we can get such and such performance. So when we actually make these devices, it's usually in silicon. Um, I guess the primary reason really being that we have like these great clean rooms on our campuses where you can do a lot of micro and nano fabrication techniques that are really well developed, and you have access to really fancy tools that all work for silicon. And so we always say like, oh, well, since chips are made out of silicon, this also makes sense because you could fabricate this cooling structure on, the backside of the chip where you're having your electronic components.
Gotcha. So you're saying so yeah, I know a lot of academia is very model based. So you're saying you do a lot more initial model creations from like pen and paper, what that might look like mathematically. And that's kind of what you're working on is coming up with the mathematics and the language to describe the behavior more than the right now, the manufacturing techniques and stuff like that.
Yeah, I'd say so. Like, I think people in my lab, we do pretty much 50-50 on modeling and fabrication and experimentation. So a lot of it that we do is like, you know, develop a model uh, to describe like a certain, structure that we want to make. But then we have to go and make that and, validate that the model works and, usually also do some optimization. But
Got
yeah, oftentimes here in academia, we're not making something that's actually could, you know, directly go to scale for an industrial application.
Yeah, that makes perfect sense. And I always try to, I think I've learned that the distinguishing factor between research and working in industry full production. But I mean, you're talking, it could be depending on the context and the subject, anywhere from 10 to 20 years before it's in full scale production in everyone's house. Because like you said, you're coming up with the theory and the math behind it. And that's the hard part is doing that as one side of it. And then another hard part is practically applying it at a mass scale. So I'm glad you kind of brought that up.
Exactly. Yeah, that's very true.
So more into studying at MIT, what do you like the most about studying?
Oh man, I guess I mean I don't know. It's hard to compare because I only study at MIT, but um, I don't know. I have really great friends here. Like I don't know, graduate students here at least I find like really nice, like down to earth people. We have a great community. Um, yeah, I mean, there's lots of great facilities and like room to collaborate with people within your group and other departments. So yeah, I mean, I guess I've really enjoyed my time here a lot.
Your time there. How have you seen any major differences compared to your when you were at Syracuse, or is it
Yeah,
been mostly a smooth transition?
I don't know. I mean, I guess it's a big transition to being a graduate student. So I mean, there's a lot of difference there. Also, MIT is purely a tech school, so I think that changes the environment a lot. Like everyone here, or nearly everyone here, is an engineer or scientist versus Syracuse being like a full liberal arts college. Like,
Yeah.
yeah, things are different.
That makes total sense. I could totally see that. Yeah, it's a lot more of a diverse setting in terms of different majors in Syracuse, where they're at, MIT is all technical. But
Yeah, exactly. I mean, I really like it here as a grad student, but yeah, I'm glad I went to Syracuse as an undergrad. To be honest, it's
really,
nice to be able to see everything else around.
that's a good point. I'm glad you brought that up. So,
Yeah,
how hard would you say that MIT is compared to your experiences at Syracuse versus?
yeah, that's really that again. That's very tough because grad versus undergrad. I mean,
Yeah,
I've kind of noticed that, like for undergraduate, the like the ABET accreditation makes it so everything is very uniform, right? Like undergrads at MIT take the same classes that I took.
exactly. I take the same.
And they like to complain a lot about how hard it is, but I mean, I don't know. Undergrad was really hard for me too, and I don't know. I mean, I feel like I'm just as prepared for grad school at MIT as my peers who were also undergrads at MIT. So it's really hard to say, I think. I mean,
Mm,
obviously, I think an undergrad here would have probably more pressure or something, but I don't know. And then, as far as grad school, I really don't know how to compare to others, but
I was gonna say, well, yeah, you can't compare it. But has it been challenging for you, or has it been mostly like? Because I know some people. I know for me, even when I went to grad school, I thought it was harder than I thought. I just say that, at least for me. But that's just me because, and I know my weaknesses and I know my strengths. But I was also very overloaded with other personal things. Like I worked a lot outside of school, so
yeah.
I was surprised at how the math jumped for me. Yeah, like
Oh,
the
yeah.
difficulty. That was the biggest part. The
No,
concept
I
was
agree. It's really challenging. Like as a grad student, you're definitely asked to like grapple with really tough concepts and courses are hard. And yeah, there's also that balance between like dealing with your coursework, but then you also have some pressure to be moving on with your research.
Mhm.
Yeah, it's quite the balancing act. I think it's
Yes.
really hard. The classes, like some of them can be really, really challenging.
Yeah, yeah. And it's like at the same time, you're like coming into adulthood. Of course, you're doing that as an undergraduate, but it's even more pronounced as a grad student. I felt different. I
Oh yeah.
felt like more mature. So I'm glad you brought that up. Uh, what's the hardest course you've taken there, you feel like, from a technical perspective?
Yeah, I think the two courses I took my very first semester were the hardest: fluid mechanics and numerical methods.
Oh, those
Just
are the two hardest courses I took in graduate.
yeah, I think those are two pretty common ones. Like fluid mechanics, tough math, tough
Oh,
steps; numerical methods, brutal coding.
yes, man. Woo, man, it's a different ball game. Especially I had Lawal in the grad school and undergraduate. He was a tough teacher, and I don't know. You're right. I'm glad you brought that up. I'm glad I'm not the only one.
Oh yeah, those were. And for us, fluid mechanics it's a course that they teach it with the intent that you might take like the PhD qualifying exam in that subject. So uh, basically, like here at MIT as a grad student, you know that if you're taking the class that has a qualifying exam associated with it, it's going to be really hard.
Yeah. Yeah, funny enough, I peeked at a few. I was curious to what like qualifying exams consist of. And I know they have the Aero Astro program, I think they call it there. And I was like, oof. Have you taken your qualifying exams?
Yeah, I did a couple of years ago.
Oh, a
Thankfully,
couple of years ago. Wow.
yeah. Yeah, so you can here if you start as a master's student and transition to PhD, I actually took my qualifying exams before I got my master's degree.
Wait, what? Oh, you mean like
Yeah, if
before
you've
like
decided that you want to move on, then
oh, okay, gotcha.
you can take it as early as after 3 semesters from
Oh,
starting,
okay, gotcha.
just to get
Oh,
out of the way.
okay. Wow, that makes sense. You just knock it out, and they're just like, as long as they can see that you're academically strong, they're like, okay, we'll knock it out. You can do your research. Was it like I'm sure it was pretty hard. What was it? Just fluid mechanics? Like you're a mechanical engineer, so they probably did what fluid mechanics, a couple of dynamic questions and heat transfer maybe.
So they actually here they let you choose like based on certain subjects and classes. So I did fluid mechanics, thermodynamics, and heat transfer. But you can do all kinds of different things, right? Because someone just studying robotics doesn't want to do,
Yeah, they don't.
right? So there's a big variety. But yeah, it's kind of those things that among the younger students, they're always talking and stressing about it because it's a pretty tough process, to be honest.
Yeah, I was gonna say. So I'm impressed that you did it so long ago, and it sounds like you made it through. So congrats, man. That's an
Thank
accomplishment.
Yeah, I mean, it's the kind of thing that like these days, like you study really hard for it, and as long as you're very serious about it, you'll get through. But I think everyone's nightmare is that you can fail it once and then take it a second time, and after you've studied for a few months, you don't want to study more and take it.
Yeah, because then the pressure's even higher the second time, man. So I can't even imagine having to take it the second time. Man, and that was really interesting. I thought you were just getting your master's, and now that I found out you're getting your PhD, that's really fascinating because I know of how many people do I know? Honestly, I only know maybe one or two people that are getting their PhD in engineering. And
I guess you have smart friends who didn't make the same mistake as I did.
well, that's interesting. I want to hear more about that. Like, what made you decide to go PhD versus working in the industry?
I don't know. I mean, I think as an undergraduate, I ended up getting involved in research, and yeah, that was just kind of the way that my advisor kept steering me, and I was interested in doing more research, and yeah, I mean, in the future, I want to go into industry. That's my goal. I don't want to stay in academia, but I guess I just wanted to really have like a research and development kind of job.
Ah, that makes sense. That makes sense. And it sounds like, did you have a good advisor? Because I know that's critical. One of the things I've read when I read about getting your PhD is having a good advisor, finding something you're passionate about, and wanting to do research genuinely. So it sounds like you had a good advisor.
Yeah, I've been fortunate enough that like in undergrad, the advisor that I did research for was, really great, really encouraging. And in grad school, also I have a really great advisor. Yeah, that can make a big difference with
That's
graduate
awesome.
experience.
And do you know where you want to work? Like, what's your dream job in the industry? With your PhD, R&D, you can go anywhere. If you knew you can go somewhere, and money wasn't a
That's tough because I'll be honest, I've only like in this semester been thinking, okay, let's start looking for jobs and see what's out there. So, I don't know. Like, so I'm a heat transfer engineer. There's there's a lot of opportunities out there for us in like the energy sector, like especially with all these like new clean energy technologies and just improving them. Lots of jobs for us. So I don't know. I think that's kind of the area I'd like to work in. Um, yeah, I don't know. Specifics are hard. I
It's okay. I'm
looked
not
at a
there.
lot of stuff, but I don't know. I would even be interested in like working in a startup or something. I think
Mm,
what I'm seeing is there's a lot of really cool academic research. Um, like people are just cranking out papers over here, right? But a lot of these things don't get really scaled up to industry.
mm.
I think recently that's been like there's been around here like big push to like kind of connect like entrepreneurs with engineers to bring things out. So I think that could be cool too.
I was curious about that because I always wondered how much of the research that goes on at these tier one research schools is being converted. I wonder what percentage that is because I was just watching a video about the top 100 research papers, and they basically ordered it based off of citations. And a lot of the most cited research papers are actually methods versus like groundbreaking theories. So a lot of it were like biological methods for analyzing data, like things that scientists use on a frequent basis to like get things done and more efficient than it was like
Yeah.
the groundbreaking fundamental theories of physics. And I thought that was really interesting. So I wonder if that's because you guys are doing a lot of, you guys are coming up with these great theories, but I don't know if there are methods that help in production in terms of uh, the average consumer. So I wonder, like, I guess my next question is, what's the coolest thing you've seen in terms of research? Have you seen something that you feel like is going to be the next wave or future?
Oh, that's interesting. Hmm,
Yeah,
that's
are there any limitations to
Yeah,
what you can say?
I don't know. I mean, I guess I see a lot of, I think that a lot of the things that I see are like, we make incremental advances, but
Mhm.
there's a lot of us doing it. So yeah, I don't know. I've seen some cool things come out of my lab that, I don't know. It doesn't seem like, wow, no one's ever thought of something like that. But, sometimes it's just, oh, we've managed to solve this problem, and now maybe this can be a really useful device. Yeah, oh boy, I don't know that anything that I was like, wow, this could change the game,
Yeah.
right? Uh,
And it can be hard to predict too, like how it's gonna. So I could totally understand that. I was just curious. I didn't know like are the research labs or you're working, I know you said the heat transfer.
yeah,
Are you guys all in one major engineering building? I know they got, different majors, electrical, aero, where you get
yeah, they mostly separate us like that,
gotcha,
but there are a lot of shared spaces,
gotcha.
we have like our clean room where people do all their micro nano fabrication. That's just shared with everybody, just to give us all access to like really great equipment.
Was that similar to the one at Cornell like that? Where they have I know you that was
Yeah,
in
yeah,
wow.
exactly.
That was cool. I remember they took us there. I forgot what year on the tour. I was blown away. It's like the little mini Intel manufacturing plant where they actually have the silicon wafers and I forgot the process, lithography or
Yeah. Honestly, a lot of people in my lab do that. For a while, I spent a lot of time in the clean room. Yeah,
that's really cool, man. That's awesome. So, um, getting on. So I want to ask, getting into one of the last phases, getting into MIT. I just want to give people perspective on if people want to do research and they want to do it at an elite level or at least elite institution wise. I want to give people as perspective on what it's like, what the application process was like. I know it's one thing to get into graduate school. I mean, undergraduate school, you know, you do your test scores and your GPA. But typically, from what I understand with grad school, it's way more research based than just like, oh, you got a good score in your GRE or this. What was your process like to getting into such an elite school?
Yeah, I mean, I did a lot of research, but I mean, as much research as I could as an undergrad. So I felt like that's like super important to set you apart. So like trying to be as involved in a lab as you can. There's all these like summer research programs that go by various different names. I think I did a few of those, and those are really good to get into, especially because uh, having letters of recommendation is a big thing. And so the more letters you can have from a professor that says, oh yeah, Jeff worked for me, and I thought that he was a bright student and really hard worker, all the better. To have someone that you actually researched with instead of just, approaching a professor whose class you took one
I'm glad you brought that up, especially the research part about doing a ton of research as an undergraduate. If you're going to apply to a graduate school and expect a high level, because I
semester.
was.
I mean, internships are good too, right? Like I know a lot of people who go to grad school now with me who like did internships over their summers. So
Mm,
I guess maybe I think grad schools aren't thinking like, oh, you better have been a researcher and know what you're doing. Because to be honest, when I started, I think I didn't really know much about research. Like,
mm,
I wasn't very good at it. I've been like very guided as an undergraduate, but I guess probably the universities mostly want to see that, you've been really hardworking and you've taken all your extra time and tried to make something of it, right?
that's a good point. That's a really good point. About internships and research, like that was the one thing. If there's one thing I would go back and do over, I would have done right after my freshman year. That summer, I would have been involved in some sort of internship and research. Every summer, I would have done that instead of, I was a little bit of a late bloomer and I did internships later on, which is fine. Everyone's different, but I would always tell people if you do want to go into grad school, get involved in research or extracurricular activities or internships.
Yeah. I remember at maybe it was specific to Syracuse, but it was like as a freshman, it was easier for me to get into research than do an internship. And
Yeah,
honestly, I think that's really why it started. I applied for internships. Not many companies are hiring freshmen. And
yeah,
then
yeah.
we had like a summer research program, and there we are.
Mm,
But yeah, I think another big part of like the application process is like having good personal statements. Like you have to write, I think like some personal statement like about yourself and what you want to do, and then some kind of research statement. I can't quite remember how it goes anymore, but
yeah,
those spent a lot of time writing. Um,
that's
and
good.
what's good is that like all your like colleges have like people there who will help you writing these applications. So I was also applying for like fellowships and things because you get fellowships to go to grad school. So I was putting all this time into writing these things and getting advice from different people, and they're all kind of moving towards the same goal. So you work on writing one thing, you're really working on the other ones. But yeah, I can't tell you how much time I spent the first semester of my senior year just working on writing these like 2-page documents. It like takes, yeah, I don't know, it takes a lot of effort to like write those really well, and it's a lot of learning. It's a learning process.
Yeah, that's a really good. I'm glad you brought that up. The importance of the personal statement about researching who you are, because I was doing a lot of research on that with MIT and things like that. That is what they look for. They don't just want a robot. They don't just want, oh, this guy's got a 4.0 and he did.
Yeah,
Like they want to like, why are you going to be? Are you passionate? Are you actual someone who's displayed that passion in some real way where it's manifested in research or internships? And like you said, your institution is there to help you with writing, because writing these things can be difficult to try to articulate who you really are and get it across in a way that's compelling. So it sounds like you said letters of recommendation, personal statement, research and internships, and obviously the scores and all that, the minimum requirements, exceeding those. What do you think made you stand out as an applicant though? Do you feel like there was anything that you noticed that they were like, oh, we were really impressed with your research, or like did they point out anything, or was it like you got the offer letter and you were just kind of like, happy to get it.
Yeah, I mean, it's so hard to know, right? I mean, to be honest, like I didn't get into a lot of the top schools I applied to, like
Wow.
it's really competitive. And yeah, I mean, I guess just some combination of like having been doing research for a while and, probably good recommendation letters too.
Wow.
Yeah,
That's
but it's really hard to say, right? I think some say no and some say yes, and you don't really know
you
why.
don't know why. Yeah, and I did a lot of research on that too. It's like timing. Do they have the right advisor for what you're interested in? Do they have slots open for you? So you could be a perfect candidate on paper, but I heard like if they don't have the space for you at that time of the year because the advisor's got a bunch of different people. So it could be a lot of different factors and you might not know. So that's really interesting. That's the one thing I realized you can't get too discouraged when you get these
Yeah,
because there's life
another thing you
outside.
can try to do is like network well. So the advisor I had who I did research with in undergrad had been a postdoc at MIT. You know, uh, I don't know. It's kind of just part of building the network. Like, did
Yeah,
it help that he was a postdoc at MIT? Probably not, but it's just,
gotcha.
I guess, a decent way to try to network with people because I don't know, you never know.
Yeah, you never know.
And
Did you
also, those people know what it takes to get into that kind of university too. So that helps too, right?
you said you knew? Say that again.
So my advisor, like he had been a postdoc, so
So
after PhD studies at MIT. So
he knew.
just very helpful to be able to ask him about the process and get him.
Mm, that makes sense. That makes a lot of sense. Asking somebody who's been there, who knows from experience.
Yeah, exactly.
That's awesome, man. Well, congrats on pursuing your PhD. Do you think you'll finish this year or
No, probably. I think I'll take like one more year.
one more year? So it'll be like how long would that be since you completed your master's that you finished your PhD? About 4 years? I heard that's the
Yeah,
average.
4 years. Yeah,
6 years.
that's pretty normal for mechanical engineers
Yeah,
here.
that's pretty normal. That's pretty normal. Yeah, I was like, man, do you feel the burnout or you're good? Or I don't want to say burnout, I don't mean negative, but
No, yeah, I mean, I think yes. It's kind of on and off, like sometimes things are really frustrating with the research, and that's usually when I feel the burnout the most. And other times no, like it's being a grad student, I've really enjoyed it. Like the lifestyle for me has been nice. There's like I have a lot of freedom. There's a lot of creativity. Like it's all like self-motivated. So, there's a lot of really great aspects to it. But yeah, then sometimes think like, wow, almost at, 5 years of this and I'm ready to, I want to do something different. I'm ready to move on. So
Mm,
yeah, it can feel long. So definitely if you're thinking about getting a PhD, think about it hard because it's a long process and you have to, you know, you probably want to be like really sure that you want to do it. But I think that's one thing that a lot of people who, a lot of my friends have appreciated about MIT's Mechie program is that you just apply once and you get the master's and then you can decide whether you think you want to stay for more. And I think after those 2 years, most people have a good idea.
mm, mm. So do you have any words of wisdom or something you would tell somebody you wish you knew while you're going into a PhD program?
Yeah, I mean, it's funny because I think if you get accepted to a school and you go and visit and talk to grad students, a lot of them are going to tell you, yeah, yeah, find a lab that fits your research interest, but more than anything, find a lab where you think you can have a good relationship with the advisor. Uh,
Mm,
because it's someone that if you decide to stay for a PhD, it could be 6 years with, and that is, I think, one big variable about grad school is like every advisor is different. And so some of them are, like pretty relaxed, not looking over your shoulder too much, um, have no problem with you taking vacation time and stuff like that. Other advisors, not so much. So yeah, definitely if you're program, like, you know, take the opportunities to talk to the grad students like in the different labs and get
wow.
a sense of where you think would be a good fit for you, like with the advisor, and trying to attain some kind of work life balance. Because
Wow.
there's a lot of great, interesting research, like to be honest, when I started here, I didn't know much about heat transfer, wasn't dreaming of being a heat transfer engineer. I joined the lab because I liked the fit. And, now, like, well, I've done a lot of interesting stuff, and my lab does a lot of stuff that's really cool, I think. So, you can kind of, there's a lot of good things and you can find what you like.
Mm, I'm really glad you brought that up because I've heard that from doing research too. One of the most important things is your relationship with your advisor. Because, like I said, you might be
Yeah.
stuck with them for 6+ years if you get your PhD, and that's
Yeah, and I think a lot of students who are like visiting and figuring things out don't have that high on the list. They're just thinking, whose research is cool.
yeah. Even I have a mindset. I was like, oh, where's the cool research? But it's like, wait a minute, like, do I want to be? That's before we close out. I want to ask you about that. So when you're doing research, because I have no idea what a PhD process is like, and you're going out there and you're trying to add something new to some specific topic, are you literally just cracking open books and trying to come up with ways of making incremental improvements on models that already exist? And then if you're stuck, you kind of go to your advisor and he kind of nudges you in the right direction? Or like, how does that relationship with the advisor work when you're like literally stuck from a technical or theoretical standpoint?
Oh, that's a good question. So I would say definitely is going to be very dependent on the advisor and the style.
Mm,
Um, for me, there was kind of like some projects, some ideas that were laying around when I started that I got to pick up. So that was nice. There wasn't like too much pressure on me to do my own thing, but there are also other people who come and say, "Hey, I have a great idea. Like, let's pursue this." And the advisor says, "Sure." But for me, it was like, my advisor and, the senior students in my group helped me to get started. And yeah, when it comes to having a problem, so my advisor, she's the department head, so she has a lot of administrative duties
uh,
and is a little more hands off. And like she she's really brilliant and like has a real great vision for like the direction of things. But she's not always um, really up to date on like the kind of nitty gritty details of what I'm working with. But we had when I was younger, I worked with an older student who, you know, really smart and really really knew what we were doing and helped guide me. And now there's the lab has postdocs and stuff, and there's other faculty all around the university. So I
mm,
guess that relationship is different, for everyone. Uh,
everybody.
but
Good. It sounds like you had kind of a positive experience with your advisor. Uh,
yeah, really, and I can't stress enough how like I feel knowing people around me. I feel like it's those of us who have had advisors that kind of were interested in fostering good relationship with us, who had the best grad school experiences.
mm, mm. Well, YouTube, you heard it the best. Make sure you pick, if you want to go to grad school, get your master's or PhD, make sure you not only are picking something that you're passionate about in terms of topic, but find a good advisor and do your research and make sure that you're compatible in that area. But closing out, it sounds like you were applying to jobs. Are you applying to jobs currently, or can you do that while you're finishing out your PhD, or are you still just working on academia?
Yeah, I'm more at the moment looking and kind of compiling a list of companies I think are interesting and seeing what's out there. But since I'm not sure yet when I'll graduate, and I think it's going to be about a year away, I haven't started applying yet.
Ah, gotcha. All right, so closing out, what do you think what's your number one company right now, or top three?
Ooh, that's tough. There's a lab here in Cambridge, really close to MIT's campus. It's called Draper. I think they just do like a lot of like a variety of things, so it sounds pretty interesting. They're almost kind of like a transition between academia and industry,
Mm,
uh, which is nice. Um, or I actually have one of my lab mates is maybe going to commercialize her research, and maybe wants me to work with her. So we're kind of in the early stages of that. Interested to see how that goes. But I don't know. I feel like the startup thing, right out of grad school is probably the right time to try it. So I think that's
yeah,
interesting, but not sure yet. There's still a lot of
yeah, you got time.
uncertainties about whether this is moving forward. So
Gotcha. Gotcha. Well, that's awesome, man. I'm excited for you. I agree. If you do want to get into startups, I would tell you it's a lot easier to do right after graduating than it is. I'm like about 5 years in the industry now, and after a while, you kind of get settled into certain skill sets. But I'm glad that you're almost done with your PhD, man. I'm impressed, man, because I'm like, after I got my master's, I was like, I'm done. I'm going into the industry. I got to make some money because I just realized it wasn't for me to get my PhD. You realize some people realize it is, some people realize it isn't. But I'm
Yeah.
glad uh, that you're feeling good about the PhD. Do you have any
Depends
last?
what day you ask me, but yeah, generally yes.
So closing out, I'll ask the last question I always ask everybody. Do you have any words of wisdom for any students who are aspiring to be engineers, kids that are in high school, middle school? You know, a lot of people are watching this and they're wondering, oh, what is a mechanical engineer? What is that? How hard is it? But if you had to just give like a simple word of wisdom for people aspiring to be an engineer and doing what you're doing in academia.
Oh man, I mean, I think I would just give encouragement. Like, I feel like when I was in high school, there's a lot of people kind of said like, oh, I can't do that. Math, science is hard. I don't think I can do this. It's just not for me. But I don't know. I mean, I think interesting things are hard to do. Like both of us have said, grad school is really hard. It's gonna
It's
be tough.
hard.
Like there are people who support you, and if you're willing to put in hard work, you can do this stuff. So I say, don't count yourself out just because math is hard. Because there's a lot of really, really interesting things you can do once you struggle your way through math class and get it.
Mm, wow, that's great advice because that's one common thing I hear where people say, "Oh, I want to do engineering, but I'm not good at math or I'm not good at physics." And like I said, like you said it the best. You said interesting things are difficult, right? You know what I mean? Like I remember when I saw Iron Man, that was one of the things that inspired me. That first Iron Man, when he builds the Iron Man suit, and I was like, "Whoa!" What? I was like an eighth grade or a freshman, and looking at, I wanted to be able to design some aspect of that, and I knew I had to put in the time. So if you put in the time, man, in math class, and like, or if, whatever your area of struggle is, like you just got to put in the time and learn how to study properly and efficiently, and you'll realize a lot of what they teach in school becomes trivial. Like most, at least in high school and at the early levels, becomes trivial once you learn how to learn efficiently.
Yeah,
And those things that
totally. I mean, if you see something you think it's cool and really interesting and it inspires you, then you know all that passion is what's going to help you to the
Mm,
hard work to get past the challenges.
that's a great point. That's a really good point because I knew in college I was really passionate about propulsion systems. So when I took, propulsions, even though this it was difficult, I didn't care about studying because I loved it. So
Yeah,
you got to really be honest with yourself about what you're passionate about. But thanks, Jeff, for coming on. I really appreciate you taking the time. Super impressed with what you're doing, man, and I wish the best for you in academia and wherever you tend to transition into.
thanks, Jack. I really appreciate this. It's great catching up with you.
Great catching up with you too.